All right, cool. Well, let's see. My name's Ricardo Sierra, and I run the Hawk Circle Timberframes program over in Cherry Valley, New York. And we're about 11 miles from Cooperstown. So we're really close to that Baseball Hall of Fame. So we're right almost in the center of New York State. And the wind just came through and blew all of our leaves off. But anyway, we're getting ready for winter here. And a few weeks ago, I just thought, this would be kind of fun to do, would be to launch a webinar and maybe talk about some of the aspects of timber framing, just pick one aspect and, just kind of talk about it, see what people's questions are and have fun with it. I'm also here with Craig Boynton, who is my partner in teaching wilderness, or
I did my own
let's see, whoops.
Yeah, I restarted
Yes.
it.
Craig's been the person that actually taught me initially how to do timber framing and has taught me a lot. So I'm really glad that he's here too. And we run a timber framing skills class in actually coming up in about a week from Monday. And then we usually do one in the spring as well. So anyway, say hi, Craig. Say anything you feel like sharing.
Well, my name's Craig Boynton, and done quite a lot of frames. Haven't done any in about a few months, but still enjoy doing them.
Yeah. I've been thinking back on, I'm trying to think back on how long I've been timber framing after learning from you. And it's been a long time. I'll tell you, it's gone back, I don't know, at least 15 to 20 years ago. So time just marches on. And anyway, I'll just start by saying that a lot of what I've appreciated in learning about timber framing is that it's something that I can do in my own shop or in our barn or in our backyard. And it's a skill that, I like making kind of simple frames that are, what's the word I want to use? Like we build cabins for our summer camps, and we just started building them. And every 2 years, we'd add like 1 or 2 more cabins. And then eventually somebody said, hey, can you build me a cabin or a little small house or something? And before I knew it, I was building a barn and I was building a cabin. One guy wanted a cabin, but it actually turned out to be a house. When he just kept adding. Every time I'd make a drawing for him, he'd go, let's make it 12 feet bigger and put another story on, and then put a porch and another porch. So it was like a massive thing. And so I learned a lot along the way of doing this. And it's just a building form that I really, really love. And so I'd like to share it. I usually had, originally I've been a wilderness instructor and have run wilderness programs for the last 30 years. And during the off season, when we weren't teaching programs, a lot of my staff used to jump in and help us build, these different cabins and structures, and they really enjoyed it as well. So I got pretty good at both doing some of those projects and teaching as well. And so that's partly why I keep doing it, is that it's fun to watch people learn and see them kind of put it all together and then feel really good when they actually make their own things. So yeah. Anyway, man, there's a lot of people on here now. Super great to see you all. I don't know if we want to just dive in. I guess we should probably just go for it, and then we'll go through our sort of spiel, and then we can just open it up to questions, everybody. So, but anyway, nice to see everyone. Hi, Adam. Hi, John. Let's see. I'm going to do a share screen, and basically, if you have any questions, just you can unmute your phone, unmute your microphone or whatever, and jump in. Like, I don't think it doesn't bother me if you interrupt me or anything. And Craig, you feel free to add anything you want to do as well. So let's see. I'm gonna. Okay. Looking for my desktop here. Photos, I'll go with photos. Okay, can you all see this? Actually, nobody's answering me, so you're all muted.
I hear it and see it.
You can see it?
Yep. Yes.
Okay, good. All right, so we're going to just talk about mortises, I guess, for the next at least half an hour, maybe. And mortises are, I was mentioning this to Craig earlier, mortises are not necessarily the sexiest type of part of framing because it's kind of just like the meat and potatoes of joinery. But at the same time, if it's really great to master these basics of it so that your frame actually can really fit together and be really, really solid. So the mortise is typically what you might think of as the female side of a mortise and tenon, so you have the tenon that slides into the mortise, and not to get any innuendos going, but just basically the mortise is like encapsulated pretty much all the way around the tenon, and it secures the tenon by sliding in and then getting pegged. Usually, I'm pretty sure it can either get pegged or it can be pegged and wedged, and sometimes there's a dovetail in there, but it's a pretty straightforward joinery piece. And the one thing that a lot of people had questions of, and I know when I was first learning too, I'd always wonder, like, well, how do I know how thick to make it? Should I put it in the middle of the beam? Should I put it on the side? Should it be 1.5 inches or 2 inches? If the beam is 10 inches, should I make the tenon and the mortise 3 inches wide? There was a lot of questions that I had when I was learning how to do this. And the style or the tradition that Craig has taught me and how we've kind of learned is pretty much from I would call it the traditional early American joinery, historical joinery.
That's a good point. What are your thoughts on that? I know Jeremy had said about 50 basis points, but what do you think about 25? 50 is a little.
Everybody on mute if you want.
Yeah.
Richard Jeremy's email, I thought he was proposing a long distance. I like the CD because it's less of a
I'm
light.
not sure who's talking.
And it's simpler to execute.
And okay, it's quieter again. That's good. All right, you guys are still here? You good? All right.
Yeah.
Let's see. I didn't even do anything. I just kept scrolling trying to find who was talking. Anyway, so we kind of come from that traditional American joinery, and I know that there are people who do joinery that are from that they might have a lot of variations in France, and there might be like the traditional English joinery, and I know that there's probably Swedish and some of the Scandinavian countries, they might do things a little different too. But we're kind of pretty much coming from that, which mostly means that we're doing either scribe rule or square rule. And I don't know, do you have anything you'd want to add about this, Craig? Any thoughts?
The only thing I could think of is, yeah, we do a lot of what we call square rule, being early American, made here in America. And like Ricardo said, you probably won't see a lot of this in European buildings. We have, housings and shoulders and all that stuff.
Right. Yeah. And this is a Jack Sobin drawing that I lifted out of someplace. I don't know where I saw it, but basically he is laying out this idea of like where the shoulder is, and then the housing is the part that's actually cut out from this upright post here, and it's cut out there and it slides in, and the housing is something that we do in what's called square rule, where you reduce the size of this timber right here to a uniform size. So for example, in this setting, the if this beam was, say, 8 inches, the housing would be cut back so that the overall space where the housing is would be 7.5 inches. So it would be about 1/2 inch back. And the reason you do that is because typically with rough cut lumber, it's not actually uniform all the way down. You know, if you actually take a rough cut log and you pull it out, you actually measure it, it might be, you know, 7 7/8 at one point, it might be 8 1/4 at one point, it might be exactly 8, and all different sides might be just off by a tiny little bit. So by reducing it so it's standard, it means that you just have to put that housing on, and it just makes it standardized and makes your joinery come out really, really nice. And you do the same thing over here for the tenon. You would reduce that down. He doesn't show that in this actual drawing, but there's usually a part that's cut out over there on that side. So anyway, I want to just also mention, I think that if you have a beam where there's a tenon that goes into the post and it fits in, but it's not housed completely around, usually that's called a lap joint. And a lap joint is just where one beam overlaps the other. I don't have a photo of that, but sometimes people will put their frame together using a lot of lap joints in the beginning. I know I actually have built with lap joints a lot when I'm using logs. I would like cut one log, cut the other, and just lap it over and then bolt it and stuff. That was back before I knew what I was doing. So anyway, anybody have any questions or thoughts or anything with that? This is pretty simple, I can imagine, for most of you. So hopefully you're good with that. All right, I'll just jump in here, I guess, and see how am I going to scroll through here? Okay. So here's another view. This is kind of a 3D view where, you know, the tenon gets slid in to this space that's cut in. So pretty simple. That drawing actually kind of messes with my eyes right now, just looking at it. So I'm going to skip through it. It's kind of annoying. I didn't realize it when I was looking at it when I downloaded that image. Okay, let's see. I'm trying to figure out, usually when I do photos with this, it just kind of scrolls right through, but for some reason while I'm screen sharing, I don't know if I'm just seeing something else here. All right, come on. Come on, little fella. So while we're waiting for I've got the beach ball of death here that's just spinning. But while we're waiting for this, one thought I had was just to ask all of you, or to mention that one of the problems that happens with a mortise is that you're measuring everything in terms of its space and how it all fits. But because it's on the inside of a beam, it can kind of be a little bit tricky to get all the dimensions right, especially down at the bottom of the mortise. And so that's part of one of the problems, I think, that sometimes people will have when they're working on this. And I don't know why this is spinning like this, but it is. So hopefully I'm not having to restart my stuff. Come on. Okay. Well, I'm surprised that my Zoom is actually working if my computer looks like it's freezing on part of it, but apparently maybe it's just the photos section.
You could try unsharing your screen and reloading.
Yeah, I'm going to do that. I'm going to just stop the sharing and then see if that helps. Okay. And now, yeah, it's still spinning here, but maybe I can actually come up here and just reboot it because that probably will help. Yeah, it looks like it's just not responding. So I'll force that to quit and then I'll open it back up again. Anyway, as I reboot this, yeah, one of the things that happens a lot, and I didn't actually take photos of this personally as I was looking through, and getting photos for this particular program, was that I didn't have pictures of, what typically goes wrong in a mortise as you're cleaning it out, especially in the beginning when you're first learning. So I figured that, we could try just talk about that for a second, but I'm going to try this and see if I can screen share it again and maybe it'll work. Hold on. Thanks for your patience. Okay, hopefully you can see that.
Yep.
All right, so this is just another version of it. I basically have just kind of skimming through this. And so you can see this is kind of a drawing that's colored, and then it, kind of fits right in. And that's what it would look like finished and enclosed. And whenever I was looking at Timberframes when I was first starting out, I kind of would see the joinery, but I never could see what was inside. So I kind of I always figured there was like a big secret, or, I didn't know if it was like really wide or narrow, or if it was like perfectly fit in exactly. So it was a little bit of a mystery until I started learning. And these are mortises in here that house the braces, these knee braces, and then there's also the top, the post mortise, where the mortise comes in and sits on the top of the post. And you can see in the photo kind of what that looks like too. This is a sill beam. And this one has 2 pegs. I don't usually put 2 pegs in, but you could, I guess. And this sort of slides in, and it's when they're laying there horizontal, holding up your frame on the outside and or being part of a floor joist and stuff. And you can see in the actual photo, the 2 pegs, and this is the post where the bottom of the post sits in. There's a mortise there as well. And that's usually pretty shallow. It's called a stub tenon that goes in. And I don't know if it's called a stub mortise or not, but probably would make sense to do that. And stop me if anybody has any questions, or Craig, if you want to mention anything. So in here, this is a photo of, or a picture of what's called a spline. And when you're running 2 beams, when you're running 2 beams into a post or into another beam, oftentimes there isn't enough of a mortise that you're going to get from each of these, because they're going to be so short when they go in there. There isn't really a room to peg them and have them really fit in. And so what they'll do oftentimes is make a through mortise. They'll run a mortise going all the way through the post right here, and then they'll slide in a piece of wood that's cut exactly for that. That's called a spline. There may be other names for it as well. I don't know if you've heard of other names. And that acts like a tenon, and it's pegged on either side so that it can't move. And so, and it's, the longer it is, probably the better it is, the stronger it is. I don't know whether or not they actually peg it here in the middle in the post, but it looks like they don't, at least in this picture here. And you can sort of see in the photo, the photo doesn't match the drawing. It's a little bit shorter. That spline is actually pretty small, but it looks like it's a different color wood. So it might be, usually you'd want that to be hardwood. If this wood is pine or hemlock, you might want that to be oak or maple or cherry or something that would be really strong. Have you done a lot of work with splines, Craig?
No, nope.
Yeah, it doesn't seem like Jack Sobin uses that a lot, but I do know other framers that do use it, and they seems to work pretty well. But
Yeah.
I haven't done it myself too much.
You could see where you might need it,
Yeah,
where it would be good, but yeah, I've never done it.
yeah, absolutely. So this is a rafter, a mortise going into, two rafter ends kind of sliding in together, fitting in, and there it's kind of housed. One rafter is sitting on top. And if this is nice and strong, based on the angle and the forces that are going on, it can be a pretty strong way to go. Typically, I use instead of a mortise, an enclosed mortise, we just use a fork, which means that it actually goes all the way through to the top of the rafter and all the way through, which then instead of having this little kind of cut down stub right in here, you're actually using the whole width of the beam. But I don't know whether it's that's better or not. I don't really know. That's just kind of how I learned. And so, that's kind of what we do when we learn. We're like, oh, this is how I always have done it. But it does seem like that would be pretty strong either way you go. And typically at the top of the roof, you don't have a whole lot of stress if the rest of the building is secure down below. Have you used this method at all, Craig, for this particular type of mortise?
I don't think so. No, we usually use like the tongue and fork,
Right,
and I have tenon into a beam, like a ridge beam,
right,
which
right.
is
Yeah,
with the tenon would go the other way.
the tenon would go the other way.
Right. And that would go into it like if it had a beam on top. And then it would be
Right.
tenon to the beam, both sides.
Right. Totally. Okay.
Ooh.
This is a mortise that's called a through. This is another example of a through mortise, and I think this is like a Dutch style where it kind of slides all the way through, and then it's wedged. And the reason that this tenon, this big space here, is so wide and so long. I mean, it looks like a canoe paddle or a cutting board or something like that kind of going through. And the reason that it's so long is that you need a lot of wood on the back side of these wedges to hold and secure without breaking, because that area is that this is laying here. And I don't know if you can see my cursor. It's like that area has got to be fair. It's not that thick, but it's got to hold those wedges and keep it from backing out. And as long as there's not a lot of pressure on that tie beam, you're probably going to be just fine and it won't break off or whatever. And I know that having the pegs in there help as well. I haven't really used this method, although I have done through tenons with dovetails sticking out the other side. We just didn't ever wedge it. Have you used those before, Craig?
Yes. Yeah, we use that in at least one barn. We did a lot of those tenons like that.
Yeah, I think from what I remember, it was very common in a lot of early Dutch barns. That was a Dutch style, and I'm not sure exactly what the best advantage is. A lot of these were kind of looking at a microscopic piece of the frame that would be fitting into a larger structure. So, we're kind of just doing a minute dive into this. But if you actually saw a picture of the frame of a Dutch barn from a bird's eye view or backing it up a little bit and seeing the whole frame, you get an understanding of how the forces of the structure are fit together, and it really makes sense.
Yep, and you can see in that other picture, well, in this one too, you have like that dovetailed.
Right.
The house.
Right. You have a bevel. Yeah, the housing there and the is beveled there. And that's actually something that is really nice, because especially if this beam that's fitting in is big and heavy, you kind of want a little bit of weight for that to sit on as it is sitting in there and being pegged there and then lasting there forever. The more of this whole beam at the bottom of this whole beam, if that whole beam is actually held by the post, it is going to support the overall weight of the whole thing a lot better. You know, most of the time these joints, they'll last for 20 or 30 years. It's really like, you know, 100 years later, you might notice that there's a little crack forming, and then another 75 years there might, you know, and especially if the foundation moves or the, you know, you get heavy snow load or somebody cuts out a bunch of braces or something in your building, eventually that might start to break. But I've used this mostly when it comes to big tie beams going across, you know, when you have like a 26-foot span and you want it to rest in those posts. That's when we really want to make sure that we
Like 3 days ago.
we get that down.
Okay.
So yeah, does that make sense? Anybody else have anything that they can think of? All right. All right. So let's see. We'll keep moving through here. This is just an example of a tie beam or some other beam going across and going up into a post with 2 pegs. And then you can kind of see how a brace will fit in at the bottom and then also fit into the tie. And so you'll oftentimes have, you know, 2 different kinds of mortises all over in your posts. And, you know, the braces are usually a little bit shorter because the brace isn't quite as big. And oftentimes a brace there might be just 1.5 inch mortise and 1.5 inches of, you know, post for the housing right in here. But then the tie beam going in might actually be, you know, a 2-inch tenon going into that because that beam is bigger. And I don't know what the general rule is as far as how, you know, when you go from 1.5 inch tenons, which are fairly standard, you know, and then 2-inch tenons, which are also standard, there's kind of a fine line. I think it's around, like for me, it's kind of around 6 inches or 7 inches. I typically will go any beam that's under 7 inches, I'll go with 1.5 inches. And then as soon as I get up above 7, I usually go with 2-inch. You know, if I'm fitting 2 beams that are 7 inches wide or bigger, 8-inch wide, that's when I usually go to 2-inch wide mortises, if that makes sense. I don't know if you have a rule that you follow, Craig, when you're doing it, but
No, that's pretty much it, depending on how big the beam is. So if it can support the 2-inch, then we'll use the 2-inch. But yeah, sometimes the beams are just too small and you have to go to 1.5 inches, and 1.5 inches is fine.
right. Yeah, you want it. The tricky thing about mortises is that mortises actually, when you take wood out of a beam, out of a piece of your structure, you're taking that wood out and it's kind of weakening your structure. So, but once you put wood back in and peg it and it's part of the structure, it actually kind of works again and it can be held. However, if you take too much out, it can be problematic because some people, I know I've seen like Japanese style frames or where they have, you know, or, you know, they might have like 3 tenons cut in going into a big beam. And that's, number one, a tremendous amount of work. And number two, if it's only 2, you know, if you take a 10-inch beam and you cut out 2 inches, 2 inches, 2 inches, you take 6 inches out, then you're really left with not that big, you know, you're left with a big weak area in your frame. You know, that now, don't get me wrong, I don't want anybody who's like a fan of Japanese thing to start, you know, bashing me on Twitter or something. I don't want to have a Twitter storm, but I think that, you know, one of the reasons that Japanese framing is different is that they don't use a lot of diagonal bracing. So they have a different, what's the word? I don't know if it's philosophy isn't the right word, but their design features are different and uniquely different than like traditional American joinery, which does use a lot of these diagonal braces, which are really important. All right. So so this is a beam. I just I ran out today right before this workshop and when the sun was still sort of half out. And because I thought, I better just show people how to lay it out, lay something out and do it. So this may be fairly rough. Anyway, this is I think this is a 5x5 beam, and we're just staring at the top view looking down. And what I did with this was I just picked and thought, I'm going to make a 4.5-inch mortise here. So I just marked this. This was a piece of scrap wood that we had left over from one of our frames. So I marked that. Then I marked it, from 2 feet, which was 24 inches to 28.5. So I was marking that. Actually, I made it to 28. So it's about 4 inches. And then I, kind of have my two little, what do they call those, little carrots or wedges? So I've got those down, and now I'm using a tool that's called the Big Owl, and that is a square. So it's going to be pushed up against this beam on the outside, and I'm just kind of making marks on either side of my mortise. And so now I'm doing the other side. And so now I've got, you can see the two little carrots, you can see the two lines going across, and they're going over about 3 inches over. And now at this point, this Big Owl is kind of nice because it actually has markings for 3 inches over here, and it has 1.5 inch marking right there. So I'm going to draw 2 parallel lines. This is what they call a Big Owl, or the Al Borman layout tool. And I don't think that they sell these that much anymore. There was a guy that was making them. I don't know how much they are running right now, but I think when I got it, it was like $95, and then it went up to like 110. And now I don't know who's actually making them and if somebody has a patent on it or what the story is. But you could actually make one of these. I know guys that have made these with plywood and used them, and they're super handy. But you can also use a square, or you can even just use a tape measure and use a straight edge too. So here we have this mortise, which is laid out, which has a line going across the bottom and across the top. And we have these 2 pencil lines here. And my pencil was sharpened very, very quickly. So it's kind of a fat line, but this is just more to show you what you would do if you were, starting to work on a beam. So after I make these lines, I usually want to try to measure and mark that so it's really clear, especially if I'm doing the layout. Oftentimes I'll do the layout on an entire beam, and I might have 6 different tenons or mortises or whatever on that beam. And so I'm usually not drilling it exactly right at that moment. So that's when I want to make sure that I can say, here is where the mortise is. So I put an X, kind of starting from the corner at one end, and an X here at this end. And then I do the same on the other side. And then I usually write, now this photo's kind of turned sideways, but I tried to mark 3.5 inches deep, just so that you would be able to know, hey, when I drill this, I want to drill it 3.5 inches down. That lets me know. Usually I can tell by the placement of it. And if I'm paying attention to the beam, I usually know it's 3.5 inches or it's 4 inches, depending on what tenon is going in there. But it's always nice to write that down just in case you're not the one drilling it, to just be aware of that. So this is 1.5 inches wide. So there's 1.5 inches of this beam, and then there'll be 1.5 inches hole in here. And then the remainder 2 inches is on this outside, or the inside of the building, will be left alone. And on this drawing here, which is now you can kind of see it a little bit better, it says 3.5, there's the 2 X's. And then in where I extended the line, I actually dropped these lines down a little bit over the edge. And now I'm going to draw and measure and put in the housing. So I'm going to come in here. I'm going to lift I'm going to go from the bottom with this Big Owl, and push up, and you can see that it goes from, if this is a 5-inch beam, I'm going to go from the bottom of this beam up to 4.5 inches, which you can kind of see here in the picture. And once I make that drawing on there, that line, then at that point, I know that that's where I want to make sure that when I chop that part out, that I don't go any further than that. And then I usually put little X's in there, which this is a kind of an older beam that's sat out in the rain all summer. So it doesn't really show up that well on a fresh milled timber. It would actually show up really nice and clear, or if I sanded it or something. But it was getting dark, and I knew that I had to come here for this class. So it's like, right, these X's aren't the greatest. So now at this point, you would have to dig that out to get that to 3.5 inches. And you can do that a lot of different ways. In the old days, they would use, you know, I don't know, they might just use a chisel. I've actually made mortises because I didn't have a drill with me, and I just took a chisel and chiseled back and forth all the way across, and then, you know, taking off like a 1/2 inch at a time. That is really not fun to do. And if you think about building a whole house and doing that, you lose your enthusiasm really fast. So the best way to do that is to drill that out, to get a drill, either you know, like a brace bit, or to use a boring machine, or in my case, we use a large drill that's 1.5 inches wide that drills in and will basically take out the bulk of the wood out of this little chamber. And on I have an 1.5 inch chisel here. I've got my rawhide mallet, and then I also have a chisel here called a corner chisel. And you don't really need a corner chisel for, you know, I know lots of framers that just don't even have it, and they're like, oh, couldn't be bothered with it. Typically the people that I know who don't like corner chisels or don't want to get one are people that use what do you call it, the machines,
Chain mortiser?
the chain mortisers. Yes, if you have a chain mortiser, the chain mortiser will hog that out really, really well to probably, I don't know, how close to the edge do they usually go, Craig?
Oh, they can get right on that line.
Right. So then you're just literally taking your chisel and just sort of scraping off, you know, maybe an 1/8 of an inch or something.
Right.
So if that's the case, then you would go, why would I ever buy a corner chisel? That's crazy. But if you're drilling, when you drill a round hole and you're trying to get it square, there's usually a good chunk of wood in there. And that's why you want to use that corner chisel to kind of get that out and make it nice and clean. And so anyway, I'm kind of going through these fast. So Craig, anybody feel free to jump in and just let me know. I think you guys can still unmute yourselves. I'm pretty sure, hopefully. But anyway, in here, I just kind of held my chisel here, and I pound lightly on the top just to kind of do what they call scoring. So I'm just kind of like pushing this chisel down and going in about maybe a 1/2 inch, maybe a 1/4 inch, just to keep the edges of this mortise, you know, where I've drawn it. I want to score that all the way around, so that if I score it, when I go to drill it, the drill as it spins around isn't going to rip out the top of that mortise. And to be honest with you, I probably score it about 30% of the time. If I'm in an area where I know the beam is going to be exposed and people are going to see it, then I want to make sure it's really nice and visible and perfect. If I'm doing like the back of a barn, like up high somewhere, I'll just drill it. And if a chunk of wood falls off, I don't really mind so much, especially if it's my building. I'll be like, I don't really care. And I won't necessarily take the time of that. But I know people that are purists, and they're like, I will do the perfect job on every single thing ever. And I'm like, okay, see you in 5 years, whatever it is. But you know, you can get fast at it. And if you just make that part of your plan, it's pretty good. Do you do a lot of scoring, Craig, when you do yours?
Mm-hmm. Yep.
Yeah, it's a really good idea. If you're building a house for somebody and they're like, hey, this is going to be my pride and joy, then I would go all the way out. But if it's, if I'm making it for like my woodshed, I mean, who am I making it perfect for? The mice. So I tend to try to get it done, if you know what I mean. So this is a close-up of the chisel. And one of the things that you notice in there is that there's a little, I want to call it like a little mountain peak in the center, in the corner. And that little spike coming out, there's probably a name for it. But that little thing is actually a guide. It actually helps you to kind of keep it going nice and straight as you go down into the mortise, along, keeping those two planes going. These are not fun to sharpen personally. I'm just gonna tell you that right now. And you can see, like this chisel's a pretty old one. It's like a hand forged chisel I got off eBay like 15 years ago. And you can see where I've ground it down, and it's not exactly, I probably should be ashamed, and I'm probably going to get a lot of people yelling at me for seeing this to make it perfect. But it's one of my favorite chisels. But I will say that, if you get that nice and sharp, it really does cut through wood really nicely. If you have a dull corner chisel and you try to smash through that, it will crush your wood, especially if you have like pine. You will see the wood compress and kind of be separated around the edges of your mortise in those corners. So just like you would if you're smashing it down with a dull chisel anywhere else. So I can usually tell when I look at some of my students and I see that they haven't sharpened their chisel in a while, because I'll just look in those corners. I'll be like, you might want to sharpen that up, buddy. Okay, so in here, this is actually, I didn't have time to drill it and demonstrate it. So I just put another, this is one of my examples of a tenon. And this is a combination square. This is just a little one. I get these like mini combination squares, but you could get a full size one. And they are really handy because you can set them exactly to the length of what it should be. You can set it at 4 inches or 3.5 or 5 or whatever. The mini ones only go up to like 6 inches, but if you get a full size combination square, they're really handy because you can kind of go all around the edges and make sure that it's actually straight. And you want to make sure that it's straight up and down. And in the beginning, it's really common for people, especially when they're drilling. Sometimes they drill all of the holes at an angle. And so, it's kind of a parallelogram in there, where the top of the hole is where it's supposed to be and the bottom of the hole is like a 1/2 inch over, on one side. And other times when people are digging it out, they'll actually dig it out and it'll look like a cave, it'll kind of be going down, straight down. And then at the bottom, it kind of balloons out and they took way too much out. I've seen that happen. Other times they just, are digging around in there, especially if you have like a knot or something, they'll dig around there and chunks will come out. But it takes a while to learn how to get those really straight and to take your time. But the slower you start in the beginning and the more careful you are cleaning those out, the less hassle you have when you're putting it together. And, you really want to make sure that it is actually going to be exactly what it says it's going to be, because there's nothing worse than when you're raising a frame and you've got like 15 people helping you and you go and you put something together and it doesn't fit. The tenon and the mortise. The mortise is too small because you didn't quite clear out all the edges and everything. Or if it goes halfway down and then it gets stuck and it doesn't fit. So be taking your time and getting the mortise depth and the edges and the corners and everything just right is really important, because it'll save you time when you're raising the frame. It'll save you time, just not having to go back and fix it later. And it's something that is, just a good practice to have so that your frame really will come out just right. I don't know if there's anything you'd want to share on that. I'm kind of just blabbing.
No, I think. Yeah, that's good.
You're okay? Okay. Good. All right. And then the last thing I think this is my last photo, is that I used a actual framing square. So my framing square is, this is the 1.5 inch size, and it goes down in, and you can use that square to kind of sweep back and forth and then see, does 1.5 inches fit all the way through? And so that's a nice way to check as well. I do know some people that actually have an actual wooden piece that fits in there and slides back and forth, and you could kind of experiment with different ways. Do you use anything besides combination squares and the framing square, Craig?
No, we just use framing squares and combo squares.
Right.
Just to make sure.
Yeah. All right. Let me see. I might be done with this. Oh yeah, I can't go any further. This is it. This is what I did.
Okay. That looks good.
All right. Well, I'll stop sharing, get us back in here. And yeah. So anyway, that's kind of my deal. Oh, wait, here's a whole bunch of stuff in the chat. Thanks, guys. Why is the housing at an angle? Somebody wrote. This was at 7:25, so that was a while ago. Mark Lockhart. Why is the housing at an angle? You mean you're probably talking about the beveled.
Yeah, the beveled
housing, is
a
that right?
beveled picture side by side with the earlier housing.
Yes.
What's the advantage of not housing the top?
I don't know. It might just be a style thing. I don't know. Maybe it's just to keep more of the wood in there, but just to give enough at the bottom that's where it's going to really matter, because the top doesn't really matter because it's not going to hold any weight. So it leaves more meat on the post, but the bottom is just going in. I think it's only about it. I usually only take it about 1 inch when I go in. I go 1/2 inch for the housing anyway, and then I go in an additional inch for that, on like a 8x8 or a 10x10.
Okay, thanks.
What about you, Craig? What do you think?
Think you got it right.
Man,
I think that's it.
I'm on a roll. I'm on fire. All right. And then John Orsmond at 7:30 said, is there a rule of no more than 1/3? So let me see if you're still on here and you want to explain your question, that'd be great.
Yeah, you were talking about the size of the mortise that you make in relationship to the lumber, and it seemed like all the way up to about 7 inches, you were using 1.5 inches. But I was just wondering, if you start going smaller than 6, or do you need to shorten it up so that you're not taking more than 1/3 of the lumber out?
Right. So if you have like a 4x4, you're thinking?
Right.
Yeah. That's a good question. I mean, honestly, I don't tend to like to use 4x4s anymore because they feel so spindly and they tend to warp and everything. So I'm almost always going with like 5x5s or whatever for parts of my frame. But when I do use a 4x4, I still kind of do 1.5 inches, but it doesn't give you a whole lot. Then it's almost like 50-50 really, right?
Yeah.
Right.
What do you think, Craig?
I'm not sure that there's any rule of thumb, but it does seem to work that you don't want to do more than 1/3. But I bet you there's no real rule of thumb.
Right.
It's kind of the way it works out. It just starts to look weak if you take more than and it's more than 1/3.
Yeah.
But yeah, if you did a 4x4, like a lot of times we'll do 4x4s and we'll have 1.5 inches and then 1.5 inches tenon, and that's half.
Right.
But we don't usually use 4x4s for beams or posts or anything like that. They're more girts and frames for windows and doors.
Yeah. Yeah, that's right. And if you were doing, like, say you were doing I don't know, a goat barn, and it was just something really small and it had a little tiny roof on it, whatever, then you'd probably be able to get away with that and go 50-50 or whatever, and it'd probably be fine. But if you're actually, putting it in a structure and you're like, okay, I've got a 30-foot barn, you might not want to use 4x4s for much of anything in there, except maybe like one of your braces or something, or if you're using them as like studs, like studs for your walls or whatever.
Traditionally, that was used a lot.
Yes.
Studs.
Yeah, you would use those 4-inch 4x4s or something like that. They would just slide into those pockets.
Right.
Right on. And let's see, the bevel, this is Todd Birch. The bevel provides a ledge. Okay, you're just answering the question up there. Yeah, absolutely. That's exactly right, Todd. You got it. Right. Yeah, you're basically just trying on that beveled side to keep the weight of the entire beam resting on the tenon, because the tenon is only either 1.5 inches or 2 inches. And you don't really want to put, if you ever have lifted a 20-foot, 8x8 made out of oak, that's pretty heavy. And even though oak is really strong, having it all rest on that tenon is, and because it's vertical, it's definitely strong, but it's definitely easier to give it a little something. Just give them a break, right? Give them a little something to hang on to for, 100 years. It's probably not a bad thing. And, usually you'll have supporting beams underneath that, like posts or something in there or a wall, but it is nice to have that. So, and that's pretty standard in pretty much most of all the joinery I've seen, is that you're going to put those housings in. And, if you're looking at one of those beams and you're putting it together and you go, yeah, that looks pretty heavy, you might just go, all right, this might call for, this calls for a beveled housing. And then you can spring into action and figure it out. And I remember a lot of times when I'm working with students and they are working with me on a big project, and they will actually say, okay, it's time to do this. There's this like panicked look. Now the beam is of course laying on its side, and I start to draw it out, and they go, what, are you sure? Can I do this? Like, because they're used to reducing that housing with chisels, where it's all even on one side. It's just a level, parallel to the bottom of the beam. And they kind of panic, but then I just tell them, just cut to the line. It's not that big of a deal. You're just cutting a little bit more on this side. It's not that big of a deal. And then they do it and they check it with the square and it looks great. So then they're kind of feel super happy. They've got one more skill that they have that they feel confident about. So anyway, it's kind of fun to see. I know for me, whenever I do anything I haven't done before, I do have like an excitement because I'm doing something new. And then I have like B, a freak out of, am I going to cut this, whatever, $85 beam and screw it up? And then I have another, and then I go like, okay, can I do this? And I have to kind of build my confidence up or whatever. That's really normal. Anyway, here, it's especially normal for me when I like go, okay, I had to order this wood from the Amish and I had to go drive all the way out to the Finger Lakes to pick up this thing with white oak. And I got just enough beams to do it. And then, so that's really part of my panic too, is that I know if I mess it up, I'm going to be waiting for like 3 months to get the next one replaced. So anyway, there's that. Okay, yeah, Mark Lockard wrote and said, can you talk about peg placement? So yeah, anyway, you want to take this, Craig, for a sec?
Depending on the size of the tenons and mortise, we usually will come in off of the housing edge 1.5 inches. And depending on how tall the mortise is, then we may use 1 peg or 2 pegs, and sometimes put in the middle if we use 1 or 2. Sometimes if we use 2, we'll come in off the edge. We'll just make something up like in 1.5 inches. So it'd be 1.5 inches, and that's where our placements would be. But usually 1.5 inches off of the housing. And we always draw bore everything so that it pulls it tight. I don't know if you want to go into draw boring a little bit, but just the
Right.
holes are up.
Yeah, that's usually where the tenon, the hole in the tenon is offset by about 1/8 of an inch, would you say?
Yeah,
Yeah, they're offset a little bit so that when when it goes through and fits in, your peg's gonna go through the mortise into the tenon, and then the tenon is actually gonna get pulled in down even tighter and then out the other side. Um, and yeah, so you were saying, right, like it's in the middle, so if the mortise is like a 4-inch mortise, you would put it pretty much 2 inches in the middle, from the either side. And then we usually go down 1.5 inches, right?
right. On the housing.
Right,
We
from the housing.
Yeah.
Do you ever go down, like if it's a 2-inch mortise, do you go 2 inches down, or you just always do 1.5 inches?
Always 1.5 inches.
It's
It,
good.
it seems to be a traditional
Yeah.
thing. Everyone looked at a lot of old things.
Yeah. Yeah, it's a little bit, whenever I've done that, it's really important to do something consistent throughout your whole frame. Because if you don't, then if you're switching back and forth, it's really easy to get confused. And then next thing you know, you're putting the frame together and you're like, hey, I am ready to put the peg through and I can't see any light through the other side. And then you have to get and then you're not draw boring and you're like having to deal with it later. It's not fun. So yeah, so you're saying if you're just doing one peg in the middle, and then if you're doing two pegs, I usually go in 1.5 inches down and 1.5 inches from either end.
Yeah.
So that it's like
Right.
put in there.
And right, like you say, if you make something that's easy to duplicate every time,
Right.
so you know that if 6-inch tenon, you're going 1.5 inches down and 1.5 inches up, and then you're right, then you don't make a mistake. You don't want to come up with different different rules of thumb for each thing.
Yes. Yeah, it's
big mess.
so easy to get confused. Yeah, I don't know if that answers your question, Mark, but one thing I was going to mention is that most of the pegs that we use, it's giving me the thumbs up. That's good. Most of the pegs that I've used, I think that Craig, you showed me, is that they're 7/8 or like 1 inch, or I think I've done like 13 15ths or something. I don't know, whatever it is, but it's like whatever it is either really close to 1 inch or it's about 1 inch for most of the pegs.
Yeah.
And there's only been a few pegs that I have made for really big beams, like 10x10s, and I sometimes will go like 1.25 inches for those.
Yeah.
And those are fun because they're like huge and massive pegs. And if I pull out a bucket of those and show that to my apprentices, they're just like, what are those? Oh my gosh, And anyway, it's a lot of fun. And I would say that my pegs usually fit in about 1.5 inches in on one side, and I usually try to get them about 1.5 inches on the other side, sticking out fairly evenly. Although you oftentimes, some people will cut the pegs off on either side. Sometimes they cut them off on the outside and then leave them on the inside. And there's a lot of companies will actually do this now. I've seen where they will put a metal bar in, and that will kind of like peg it with a metal bar that's kind of tapered, so they can kind of back it out later. And they will put it together with that, and then they will, once everything is all there, they will pull those bars out and then put in either a temporary peg, or they will put in like an actual perfectly round peg that's going to fit and center and everything exactly, for some frames. I've always done handmade pegs, and the more funky they are, the kind of the better I like it, because it definitely looks more homemade and kind of fun, and it actually looks more like the old barns that I really love. But you can go with that perfect one. Yeah, what were you going to say?
I was just saying they usually have 8 sides and they taper slightly.
Yeah.
The pegs.
Yeah, absolutely. Yeah. And so John, you mentioned on here, how do you make pegs? You know what? That would actually be a really good question to put in the Timberframe Apprentice group, would be to just throw that in and ask people, hey, show me your peg setup. There are actually a lot of people that have posted their peg making process. You know, some people have set up really elaborate things with a table saw that I've seen, I think, in about 3
Yeah.
months ago. And then other people have, like, you know, they'll have a shave horse and they'll sit and, you know, kind of, you know, split them and then, you know, use a draw knife. That's kind of what we usually use, is a draw knife and a shave horse. But other people use it. I know Rob Hughes, who's the other guy that's one of the admin in the program. He actually uses a table saw and a jig, and he just kind of runs it through and, you know, runs them through and gets them all square. And then he kind of runs through and cuts them off. And that seems to work really well for him. And then some people don't like making pegs at all, and they just buy them, which they find a source for them and buy them. And
Yep. Sometimes you'll see turned pegs too, which in my opinion, the split pegs are the best. They are never gonna break. You can smash them. They're
Yeah.
never gonna break.
yeah, that's true. Yeah, if they're you know, turned on a lathe, there's a chance that as they kind of grow down, you know, as the peg goes down, that it could be offset from the grain, which means they have a potential of shearing. And sometimes as you're pounding it through, it'll shear on you, and then now you're like left with chunks of wood inside and doesn't quite work. So anyway, that would be good. And then Todd has a question about mortise depth. So yeah, what do you think about the depth of mortises generally?
Well, I have a specific question. So
Yes.
I've hand drilled with a guide, and I've used a boring machine to cut mortises, and they both produce a fairly flat bottom. But I recently bought a Makita chain mortiser, and it has 3 settings. You clamp it once, and then you can plunge and cut, and then you can angle it and plunge and angle it a second time and plunge, and then you move it, and then you make 3 more cuts or however many. And so it leaves a fairly uneven bottom. And since the bottom is rounded, you kind of have to go quite a bit deeper than your tenon, or you'll spend time with a chisel to cut out those rounds. And so I don't really want to be cutting out those rounds. And so what effect, I mean, other than removing post material, I mean, is it common for people to just plunge past the depth of the tenon and then not worry about cutting the rounds and just leave it deep?
Well, when it
Yes.
comes to the chain mortises, I'm going to let Craig take this, because I've actually never even used. I've seen them used and they look really cool, but I've never actually used them myself. So Craig, go for it.
Every time that we've used a chain mortiser, because we get there round, we just go a little deep. Yeah, and we leave it rather than try to make that perfect. And I don't think that it would make much of a difference, because ours doesn't tilt though, so we just go straight down. So we're about a ½ inch deeper than what the tenon would be, and that seems to be okay.
Yeah.
Okay.
Yeah.
Is that
that's
about
what-
you're digging, like about a ½ inch or so past?
Well, I'd say, you know, with the Makita, since it has 3 different angles, to take advantage of that feature to speed things up, you know, you would be probably more than a ½ inch on the initial cut, and then maybe a ½ inch on the 3rd cut.
Yeah. Yeah, I probably think that it's not a problem.
I mean, the other option would be rounding the corners of the tenon over.
Yeah.
Right. Yeah,
And
that's
having
a
to
good
work
idea.
on the bottom of that mortise, which you can do that, but yeah, that's a lot of work really for nothing, I think.
Okay.
I
So just go deep and don't worry about it.
I think so, yeah. You're not going too much past, you know, a ½ inch, a little bit more in spots. It's probably okay.
Okay. Thank you.
Yeah. Yeah. What's interesting about the frame, when you, and I forgot to mention this when we were talking about mortises in general, is that, you know, if you're thinking about a mortise and a tenon going together. And if you could imagine that they were perfectly fit to each other and they could slide in and be perfect, that would be the ideal. You know what I mean? Like that would be the most perfect way to do this, would be to get it in there, get it perfect, peg it, and it would kind of be this one unit. And that is probably what a lot of people want to, you know, that's the goal that you would want to achieve, like your level of mastery or something. And the only thing I would like to say about that is, you know, when I work with apprentices and they're cleaning out mortises and they're, you know, they're off a little bit, you know, one side's a little bit deeper, one side's angled a little bit or whatever, is that I usually, number one, I always try to have them learn on parts of a frame that aren't critical. So in other words, like where two girts come in on a post that are really just nailers for the siding. It's not, if those are off by a tiny bit, or if they're not 100% perfect, it's not that critical. So I get them to practice on parts of the frame so they get good at it. And it probably takes like doing it 20 times before they start to consistently get it better. But the piece that I would want to mention to everyone is that, you know, if you're cutting the frame traditionally, you would cut it green and then you put it together green and then you peg it. And then the whole thing is going to basically dry out. It's going to change. It's going to shift. It's going to kind of do these little twists and expansions and shrinking. And the whole thing is going to kind of dry in a way that will be like locked in. It really locks it in once it's dried, because, you know, one beam is twisting one way and the other beam is kind of twisting another way. And so the whole thing just kind of binds, and it probably takes about maybe 5 years, 6 years to really fully dry. And once that happens, your frame's going to be whatever it is. And, you know, it may not really shift that much. And, but, you know, I've gone up onto a timber frame, you know, up on top of a cabin that we made once. And I stood up there and I was like, these beams are super solid. And I stood up on top of the frame on the roof and I kind of wiggled it and the whole thing kind of wiggled a little bit. And I was like, in my mind, I would think that it shouldn't do that because it should all be locked in so firmly. But the reality is that it did have a little bit of wiggle because some of the, you know, a lot of my apprentices had built that. But once we put the roof on, you know, put the boards on, it tightened it up too. So, and, you know, that cabin is super big and strong. So I don't think it's going to be a problem, but it's still standing and all that. But it was kind of funny because in my mind, I thought it would just be like perfect. But green wood with all the knots and the wavy grain and everything else is not, it's not like working with plastic or, you know, whatever. It's just not that type of material. So it's going to have a lot of responses as you go. So the more perfect you make it, I think there is a law of diminishing returns where you could work and work and work and work to make it absolutely perfect. And then you're still going to have shrinkage and expansion and it doing weird things. So yeah. All right. Well, hey, I don't know if anybody, I guess there's still a bunch of you on here.
I have 2 questions, actually, if you don't mind.
Absolutely. Hi.
So I'm coming at this as an absolute beginner. I know nothing about timber framing except what I've seen on the Apprentice Facebook page. So when cutting a mortise and a tenon, how much, how do I say this? How much play do you want in the fitment between the two? Do you want the tenon to be maybe a 16th bigger, so it's like it's a slip fit inside, where you might get a ratchet and force it together and then allow it, as it dries and shrinks, it still stays super tight? Or do you want to just exactly or a little bit less? What kind of tolerance are we talking here?
Well, let's see. What do you think, Craig?
We always, if the tenon is too thick, it won't go in mortise.
Okay.
So it has to be, we try to make it as perfect widthwise as possible, so that it fits in. A little bit big is okay. You know, if there's a little tiny bit of slop is okay. If the tenon is too big though, we just have found that it just won't go, and you're beating it to death to get it to go together. And so we try never to, to avoid that.
Yeah.
Okay, I appreciate
So
it.
we try to keep them, fairly tight, fairly, so that, they're right there, and they're tight when they go together, but they can't be too tight.
All right.
And it depends on the wood. If you have pine or something like that, you might be able to squeeze it in. But if you have a hardwood or something like that with knots, it'll never go together, and you'll just be beating yourself to death trying to make it go in.
Right. Yeah, I found that too when I was putting those together like that, where it's just a little bit too big, that when you start pounding, an 8x8 or 7x7 beam, and you're smashing it in and smashing it down, that's not good for the post either, because you're kind of sending a lot of vibration through the whole thing. So you can hit it some, but you don't really want to be pounding it into oblivion. Like that is, it's better to not pound it as much and maybe ratchet it and kind of encourage it, persuade it to go together, than to over pound it thinking that you're making it better because now it's going to shrink. Like it's better not to smash the heck out of it if you can. It shouldn't be something where the beam just like sits on it and just goes plop right down. That's when it might be a little bit too small.
Yep.
But if that happens, it happens.
Okay. Well, thank you both. That's good to know. And the second question is about, I guess, a mortise and tenon joint under tension. And I noticed this in a comment thread where there was a pretty heated debate on the Facebook page about should the pegs that hold the mortise and tenon joint together be the sole member holding a piece in tension. Say, for example, at the bottom of a truss, where that horizontal piece, I don't know the terminology, at the bottom of the truss is under tension from the walls pulling out. Can you rely on the peg to hold those joints together? Or should you shape the joinery in such a way that the beam itself is held in its own joint?
Right.
Yeah. I would say that you don't want to rely on the peg to do too much holding together. So in an instance where you have tension, you might want to try to make some sort of joinery that eliminates the tension to the peg. And so that, you try to eliminate all the tension in tenons if possible in a building. And it's impossible all the way. But there's a lot of old English buildings that they would lift and you could pull all the pegs out because the pegs were doing nothing. They were just holding the pieces together while you lifted it. And that's kind of the way we kind of look at things. Like, we try to make them things like that, where you can eliminate the pegs and does the building still stay standing? And so that's what we try to do.
Yeah. Yeah, I think the other thing I would just mention is that, we've used rafters. I think actually I drove up to Craig's house when I had to do this, where we were building a structure that had a nice two rafters coming together, and it was a big span. And so we put in collar ties, they call it, which go across the bottom. And we had to do a dovetailed lap joint to put the collar ties into the rafters. So we had to kind of oversize the rafters a little bit, make them a little bit thicker than we would have, because we're going to be taking some wood out of there, and then drill that in 1.5 inches, and then cut out, kind of cut out and shape those, and then slide those in and fit on either side of them. That was
And that sort of
yeah.
eliminated the outward thrust at the bottom of the rafters. So
Yeah.
you're not relying on the pegs.
Yeah. And it was definitely stressful doing that, because I felt like it was hard to get them exactly perfect and, all that, but it was a good practice to do. And it took a little bit of time, but once we started doing it, we just got into a nice rhythm and made it happen. I don't really see that used that often when I look at pictures of most frames, that I see online. that I don't usually see that type of joinery in the collar ties. So there might be there might be some other methods. And a really good book that I got a long time ago, and I have to get a new copy, but it's called Historic American Timber Joinery, a graphic guide by Jack Sobin. And this is one I got when it first came out, and it probably has a nicer cover now. But basically it shows in there all of the different joinery of every part of the frame, and it shows like historical things. He'll actually show a picture of one and say, oh, here's an actual picture of a frame in upstate New York or in New Hampshire or in Maine or in Massachusetts. And it will show variations of sill beam joints and post joints and rafter assemblies and, you know, English stuff and everything. And it's got great drawings in it. And it's really well worth getting because it lets you kind of look at what people did. And, you know, to be really honest with you, when you're doing timber framing, you can make your joint be very complicated. You know, you can spend a lot of time like doing wedge dovetails, everything else. And those are really cool to do. But if you imagine that you are, you know, doing this timber framing 200 years ago, those people, if you look at a lot of barns, they were like, hey, winter's coming, man. We don't have a backup plan. These cows have to have a barn. I have to have, you know, the babies coming or whatever, you know, we got to get the corn in and all that. So they really didn't always spend necessarily, you know, like when I look at a lot of old barns, I'm like, man, this thing, you know, I'll look at mortises and go, wow, there's an inch and a half gap in here or something, you know, that not that I'm exaggerating, but they'll have different gaps and stuff in their joinery because they were like, okay, let's just do it and get it up. And they're still standing like 250 years later. So with a stone foundation and everything. So it's, there is that feeling of, you know, getting a chance to see these things. And then, you know, some of the joinery that's in this book, there'll be a picture and he'll say, Jack will write in there and say, this is the only known example of this joinery in America that I know of. And when you look at that joint, you'll go, gee, I think I can figure out why, because it looks really complicated, like it would take a lot of time. So I can imagine that whoever was doing that building would either, you know, the guys working with it would be like, we're not doing that. Get that out of here. Do it the other way. So anyway, it's kind of funny.
I appreciate it. What was the name of that book? I'm going to write that down and see if I can order it as well.
It is called Historic American Timber Joinery.
Timber Joinery.
By
Okay.
Jack Sobin. And I got it from the Timber Framers Guild. They're you know, it may even be on Amazon right now, but you could probably go on the Guild and get it. It's definitely worth it to check out. And it's a lot of fun because, you know, there's variations in some of the joinery, and sometimes my apprentices get into wanting to do it differently and they experiment a little bit. It's kind of fun.
And one of the nice things with Jack is he looks at a lot of old buildings that have been around for hundreds of years and looks at the joinery, which is, you know, if it stood the test of time, you know, that's a good thing rather than reinvent the wheel. He's looking at a lot of old things and seeing how they were done.
Yeah. Yeah. I love that. I love that a lot. Well, I know the other thing I'll just mention before we go is that like I said, we do run a program on timber framing and it's for usually 6 days. And it's pretty much where we go and we say, all right, we're going to start from the ground up. You're going to learn about hand sawing and chiseling and mortises and tenons, and then moving up to, you know, posts and braces and all of that stuff. And we go through sharpening chisels and how to move beams safely. And then we basically start cutting all the parts of the frame. And then on the last couple days, we usually raise the frame and peg it all together and put it together. And we have a lot of fun doing it. And it's a great class. And it's, I wouldn't say that it gives you everything that you would ever need to know with timber framing, but it would definitely get you where you would have the confidence to build your own frame. If you did that, you would definitely be able to say, all right, I can build a cabin or a tiny home or a little wood shop or something, especially one of the simpler buildings, and at least get your feet wet in that and get your confidence going. And then once you build a couple things, then you can start going into like hammer beams and starting to work on the cathedral that burned down in France or whatever. You can go crazy with your project. So it's a nice way to start because it just gives you all the basics. And we don't really use a lot of expensive tools. You're really just using like axes, chisels, framing squares, hand saws. We use one electric drill, and we do other, boring machines and things like that. But it's really, it's nice because it's kind of giving you the example of if you didn't want to spend like $8,000 on high-tech tools, you could still end up building a really, really beautiful cabin or a small frame, a sauna, whatever. And you could put that together, and we show you kind of everything about how to do that. So anyway, I think it's the last week of April next year, and we have one coming up the first week of November, which is in a week from Monday. So if anybody has nothing going on, you can jump in on that. If you, we'd love to have you. I think we still have a couple spaces left for November. And if you want to sign up, we usually only take about 10 or 12 people maximum. So if you really, really know you want to learn and you want to come out, you can always take, you can go to our website, which I think I put at the beginning of the chat, and just sign up if you wanted to for next year. I think there's a pretty good discount or something if you sign up now before the 2003 price comes in or whatever. Anyway, it's been really nice sharing all this stuff with you. I really hope you guys are all doing really great. And I don't know if you have anything that you'd want us to cover in a future program, please, another webinar, let me know either by sending us an email, or you could just post something in the Timberframe Apprentice group. Just let us know if there's something that you'd want to do. I could cover some things on sharpening, or we could cover rafters or whatever. I don't know. Whatever we feel like doing. So maybe we'll do this again later next month, or make it something we do once in a while.
Do you know if there's any groups that are dedicated to like barn repair? So, and the challenge with that is, safely stabilizing the building while you're, working on that and so forth. Like how do you get that knowledge?
That's a good question. I did talk to somebody back. This is like maybe like 8-9 years ago, and there was a man that I knew who lived in the Catskills, and apparently he had a job which was he would go in and like fix like old barns, and so he would like drive out, look at the barn, do all the measurements, pick all the beams and everything else. And then he would go back and like order all the beams and then just cut them in his shop, and then eventually bring that back, take away the siding or whatever they needed to do, expose what you needed to do, slide everything in and repair it. Oftentimes you actually have to repair the foundation. Sometimes you have to jack the whole building up in order to put a whole new foundation in. Sometimes it's a really massive undertaking. Other times it's just replacing a couple of beams. And because everything is so, every structure is a little different. Every situation's different. Where the building might be failing or having a problem might be different. So it's hard to have like a hard and fast rule around that, how that works. I know, Craig, you've done more repairs on structures than I have. So you might be able to have a better piece of this, but I know, it's kind of like part engineering and then part having the joinery part. And sadly, if you have an engineer come into your barn, they'll just have you putting in cables and all kinds of, I've
Mm.
seen a lot of stuff where they just put like pressure treated 6x6s in and bolt stuff here and there. And it can get, I mean, it definitely works, but it doesn't look like the original building, and it's kind of scary. So yeah, that's a really good question. I think there definitely should be a group or a place where a lot of people that want to fix barns could gather and share tips and photos and stories and stuff.
Right. I know there are a lot of people that do that, and that's what they go around and fix barns. So there are people that would have the knowledge of, what to do. We have done a few repairs of things, and, we just look at it and kind of make it up as we go. As what needs to be held up while we remove a piece.
Sure. Okay,
Yeah.
thanks.
Yeah, there's probably like, various ways that you can do that by, clamping things or bolting on additional support beams and then, putting posts underneath it to jack it up and secure something. And every situation is different because it depends on, what you're doing in replacing. So if you're replacing something that needs to come in from the side, you can't put a post, you can't have support beams that are in the way of that. So you kind of have to imagine how that's going to be fixed. And sometimes when you're trying to fix a part of a barn or whatever, and it fails, you have to kind of find out, why did it fail in the first place? Was it because of water damage and everything was good except that it got wet and then it rotted? Sometimes it's because they took out and removed collar ties and now the post cracks at the top. Sometimes it's something else. So you don't know if you're just replacing that with a sturdier thing, or if you have to kind of figure out what actually went wrong and then figure that out. So it is kind of a little bit of a, detective engineering, historical storytelling, I guess, or analysis. It is tricky for sure.
Yeah.
And usually the barn is like filled with like, 6 generations of junk. So that's
Yeah.
part of it. And if you ever get, big on like taking barns down, I can't tell you how many times I get an email from someone that goes, "Hey, I've got a barn on my property, and if you take it down, you can have it." And I say, "Well, send me some pictures." And when I look at the pictures, it's just like, the roof is caved in, or there's 6 tractors in the way, and the siding has been ripped. It's just like a nightmare. And I'm like, my insurance isn't going to cover that. I would need a crane and, a crew of 10 guys and all that. And I'm like, I don't think there's anything of that frame that's going to be really worth it to take that down and then sell it. But there are people that will come in and take beams because they actually will put it on a tractor trailer and they'll drive to Texas and they'll put up a barn out there that somebody's wanting to put weddings on or something. And they'll sell it for like, $100,000, and they'll just take the whole thing down and boom, and it's gone. But that's typically not the kind of work that I usually do. Although looking at my bank account, I probably should be doing that at this point. But
Sure.
I'm getting on the older side, so that's probably a younger person's adventure. Yeah. Hey, well, this is great. We've gone to like 8:30, and I appreciate everybody that sort of stayed with us. So I really appreciate it. Hope you're all doing well. Thanks for being part of this. This is great. Yeah. What do you think? Should we head out? Anybody else have anything before we go?
Just want to say thank you guys for putting this on.
Yeah, no problem.
Welcome.
Thanks, Adam. Yeah, right on. Yeah, thanks a lot, Mark. All right, David Jonas, I hope it's not too cold up there in Alaska. I know you've done a lot of joinery, so excited to see all your stuff that you've been doing. Lots of spruce, I think.
I'm going to start cutting a frame in about 4 months.
Oh, nice. Yeah, that's good. That's exciting.
It's going to be cold in 4 months.
Yeah, it's going to be real cool.
Yeah,
Maybe the
it'll
chiseling
be,
ice.
I expect to receive the wood in March, probably start cutting in late March. It'll all be winter cut pine.
Oh, nice.
The result will be about a 25-foot by 45-foot queen post, barn style, monitor barn.
Oh, that'll be cool. That'll be nice. Excellent. Well, hey, please send pictures or post pictures in the Timberframe Apprentice group if you can. And yeah, and if you get stuck, give me a, send us a message or something, because there's a lot of really good timber framers in that apprentice group, and they are remarkably very generous with their time. I don't know if they're, got extra free time or whatever, but they seem to be really happy to help people who get stuck, or who are asking sincere questions, and it's really nice to see. So we're really happy with the group as it is right now.
Yep, I would agree. Thanks for the workshop.
Yeah, no problem. All right. Oh, Noah says he's actually currently chopping his first mortise. Right on, Noah. That's good, man.
Cool.
Good luck with that. Most of the time, you just have to go for it, I guess, right?
Yeah, just got to do it.
Yeah, right on. All right. Well, hey, everyone. Have a good night. Do whatever you're going to do. And awesome. Glad you were here. Right on. What do you think, Craig? I guess I'll see you in a week or so, week and a half.
That's right. I will see you in a week and a half.
Yeah, it should be fun.
Bring my chisels.
Right on. Yeah, if you want to, if there's anything that you want to talk about or whatever, let me know and we can just chat, catch up maybe sometime. I don't know how crazy you are right now, but if you want to give me a buzz in, whenever.
Yep.
Monday,
Okay.
Tuesday, next week or whatever, just to touch base, that'd be great. And
Okay.
yeah.
I should have time.
Okay.
Should be good.
Hey, did you see the picture of the deer that I got on my trail camera?
Oh. Awesome.
That thing was gigantic. I was like, what? When I saw the first video of it, it would look like it's just a little deer as it was walking out. I was like, oh, hey there, young fella. And then all of a sudden I was like, oh boy, that thing's crazy.
Yeah.
That's probably the only time I'm ever going to see that deer. But anyway, if you do want to do something, maybe we'd want to put some hides in the water for doing some bark tan or something while you're here. We
Yeah,
could
cool.
play around with something like that.
Yep. Got any,
how is hard maple for making pegs?
hard maple?
Yeah. Okay.
Yeah. I've used that
Okay.
before. It can get a little wavy. It tends to be like straight, and then right at the end, it gets a little wave to it. But if you find a really good log, I would say a lot of the younger logs, a smaller hard maple tree tends to have pretty good straight grain.
Yep.
Sometimes the bigger ones are kind of wavy. But I have used them. It's nice.
One other question about, I'm gonna be doing a timber frame sawmill shed for my sawmill. It's gonna be 28 feet long. The top plate, I'm a little confused on where to make the splice, on top of the post, or I see a lot of them where it's on the brace.
Yes.
It should be on the brace, I believe.
Yeah.
Typically, at
Yeah,
least
we always
it's-
put them.
yeah.
I
Okay.
think it's that way.
Yeah, it's something about the pressure or something, because you shouldn't have it on the post. I guess I'm really confused on that. Why?
Right. Why? A good question why, and I'm not really sure. Traditionally, it's always on the post, or on the brace. And I think it's just stronger that way. And I can't really tell you exactly why,
Okay,
but we always just do it like that.
all right.
The
So we
other
run
thing,
past
oh, go
and
ahead.
go next brace.
Yeah, depending on how many, what is it, bents you have,
Yeah,
where you're putting, like, say you have 3 posts or 4 posts, if you have 4 posts, it's better to have the plate beam in 2 posts at the same time, because you don't have as much chance for it to pivot, right? To kind of shear on either side. So if it's got 2 posts in there, it's going to really hold it in line. And then if the other one has 2 posts, it helps it. And
Okay.
but if it's actually on a post, then there's a chance that, it could move or, shear or whatever at that point. I mean, how much it actually, I've never seen anybody say, hey, look at my house. The middle of the house just blew open for no reason. Because most of the time your roof, if it's the truss of the roof, if the forces of that are working right, it shouldn't be putting so much pressure on the plate beam that it would blow out. So, but that's what they say. And I'm sure there's probably timber framers in the group that will say, yes, I've seen this fail at different times. So this is why we do it. But yeah, I've always thought about that too a lot. I used to always ask that when I was first starting to do it, and I go, oh, should I do this or should I do that? And I've done it both ways. And after I did it over the post, I have some tie beams that actually are, meeting, and there's a king post on top and below, and it's right over that. And every time I look at it, I feel guilty because I should have probably moved it over. So I have like people say, they'll come into a building and they'll go like, it's so beautiful. And I'll look at it and I'll just be like, please, nobody see my shame. But it's funny. It's super strong. So right now it's doing well. And if it does fail, it probably won't be something I'll ever see. So anyway, good luck with that. It sounds like a good project.
Thank you. If we got more questions later, can we email you on questions on that?
Sure. Yeah,
All right.
absolutely. Yeah, well, maybe we'll do a webinar on some different aspects of timber framing too, that just kind of like is a similar thing like this. We'll just find a topic that people seem to be liking, and then we'll do a little class on it like we're doing.
Perfect.
Right on. Well, good luck.
Thank you.
All right. Well, have a great night, everybody. I will see you all later. Awesome. And I'm going to stop the